Hello students, welcome to Eshwari Taniksha channel. Students, in this video we are going to learn equilibrium constant Kc and Kp and the relationship between Kc and Kp. So consider reaction A plus B giving C plus D. So Kc for this can be written as Kc is equilibrium constant in terms of concentration. Write the concentration of the product divided by concentration of the reactant. So product concentration divided by concentration of the reactant. Kp is equilibrium constant in terms of pressure. So Kp is equal to, so write the pressure of the product divided by pressure of reactant. Pressure of product Pc into Pd divided by Pa into Pb. So this is the expression. So now coming to the unit. So Kc is unitless. Same way Kp is also unitless. But this is not true for all the reaction. So for different reactions you can have unit for Kc. So therefore you can use this general equation. Kc is equal to concentration you can represent in mole per liter. So mole per liter to the power of delta n. So delta n is number of moles of gaseous product minus number of moles of gaseous reactant. So you can use this general formula to write the unit. Similarly for Kp, so Kp you can write it as Kp is equal to, so pressure will be in atmosphere, write atmosphere to the power of delta n. So delta n is again number of moles of gaseous product minus number of moles of gaseous reactants. So now let us learn the relationship between Kp and Kc. So relation between Kc and Kp. So students, now let us consider reaction H2 hydrogen gas plus I2 gas giving 2Hi gas. So write the expression for Kc and Kp for this. Kc is equal to product concentration divided by concentration of the reactant. So Hi, so this is called as stoichiometric coefficient, write in power square divided by reactant concentration H2 I2. Same way write for Kp. Kp is equal to pressure of Hi, and this you should write as square divided by P, reactant is H2, and then pressure of I2. So this is how we write the expression. So students, now we know that ideal gas equation is PV is equal to nRT. So this is called as ideal gas equation. P is the pressure, V is volume, N is number of moles, R is called as gas constant, and T is temperature in Kelvin scale. So this is ideal gas equation. So students, now we bring it to the denominator. So you can write it as P is equal to N by V R T. So now N by V. N by V is equal to C. C is concentration. So concentration is nothing but number of moles divided by volume. So now pressure is equal to concentration into RT. So students, for gas you can write pressure of gas is equal to concentration of gas into RT. So here for H2 is a gas, I2 is a gas, Hi is a gas. So for this we will express in this equation. So P of H2 is equal to pH2 is equal to concentration of the gas. Gas is hydrogen. H2 RT. Similarly, P of I2 is equal to I2 into RT. Same way, P of HI is equal to HI into RT. So this is what we will get. So now we will substitute this in this expression. So now Kp is equal to, so PHI is HI into RT. There is a square, so square for both the terms, square, divided by P of H2. H2 is H2 RT and then I2 RT. So this is what you will get. So now this is equal to HI square divided by H2 I2. So students, here this is RT square, RT into RT square. So now you can cancel this. RT square and RT square will get cancelled. So what you will get? So you will get Kp is equal to HI square divided by H2 into I2. So see this one, Hi square H2I2 concentration. So this is equal to this. You can see this. Hi square divided by H2I2. So in place of this one, now I can substitute Kc. Kp is equal to, this is nothing but Kc. So the relationship between Kp and Kc is Kp is equal to Kc for this reaction. So it is not same for all the reaction. For this reaction, Kp is equal to Kc. So we will take one more reaction. So we will take one more reaction and then we will generalize it. So second reaction is N2 gas plus 3H2 gas giving 2NH3 gas. So this is the second equation. So again we will write Kc for this. So Kc is equal to product concentration, there is stoichiometric coefficient, power, concentration of the reactant N2, H2 and stoichiometric coefficient is 3. Kp we will write Kp is equal to pressure of ammonia NH3 square divided by pressure of N2, pressure of H2 and there is 3. So write as power 3. So now students, what we can do is we can write this in terms of concentration. So this is equal to, so you will get concentration of ammonia into RT. So square is there, so put square for both. So just now we learned, so what did we learn here? Pressure is equal to concentration of the gas into RT. This is what we are using. Divided by, for nitrogen we will write pressure of nitrogen, we can write concentration of nitrogen into RT. Same way for hydrogen, concentration of hydrogen into RT. Here there is cube, so write cube and cube. So now this is equal to NH3 square RT square. So square is for RT divided by N2 H2 cube and then RT into RT cube. So this becomes RT to the power of 4. So add the power. So here power it is 1. 1 plus 3 will become 4. So now this is equal to NH3 square divided by N2 H2 cube and here it becomes RT to the power of 2 minus 4. So 2 minus 4 becomes minus 2. So Kp is equal to Kp is equal to, so students see here, so this I can substitute as Kc. So see here, ammonia square, nitrogen, hydrogen cube, nitrogen, hydrogen cube. So you can write Kp is equal to Kc RT, 2 minus 4 is minus 2. So this is the relationship between Kp and Kc in this equation. So now let us generalize it. So generalized equation is, so you can generalize as Kp is equal to Kc RT to the power of delta n. So this is the general equation for the relationship between Kp and Kc. So what is delta n? Delta n is nothing but number of moles of product. So it should be gaseous product minus number of moles of gaseous reactants. Gaseous reactant. So now let us take example and write the relationship between Kp and Kc. So first example, N2, just now we got plus 3H2 giving 2NH3 gas. So now write the expression directly. Kp is equal to Kc RT to the power of delta n. So calculate delta n. Delta n is equal to, so delta n is number of gaseous product. So number of moles is 2 moles. 2 minus reactant, how many moles are there? 3 plus 1. 3 plus 1 is 4. So this is equal to minus 2. So delta n is minus 2. You will get Kp is equal to Kc RT to the power of minus 2. So this is the equation. Second example. So second example we will take 2 times NOCl gas giving 2 times NO gas plus Cl2 gas. So write the expression for this. Kp is equal to Kc RT to the power of delta n. So delta n is equal to gaseous product 2 plus 1 is 3 minus, and here it is 2. So this is equal to 1. Delta n is equal to 1. So you will get Kp is equal to Kc RT to the power of delta n, which is 1, which is nothing but Kc into RT. So this is the expression. So students, I'll meet you in the next video.